Smartphones are an example of both everyday chemistry and sustainability. And so if you happen to have that smartphone in your hand or you're looking at it right now, think about this. So there are different components in your phone. There's mostly a plastic case, and polymers are made in a lab. Mostly plastics are polymers that originate as oil or petroleum. So we'll be getting into those types of reactions that make plastic polymers. There's also a mostly glass touchscreen, and that glass touchscreen started off as sand. So there are many different metals inside, many different metals, and metals are very important. Mostly there's a silicon processing chip. Silicon is a metal that also comes from sand. It's an element on the periodic table, the element symbol Si, but there are many other rare metals that are needed, and these are rare metals that are usually coming from exotic places and mined, usually from countries in Africa. So how does that ordinary glass that is not so ordinary, how does it work as a touch screen? Well, there are a bunch of layers, including glass, and the way the touchscreen works is by conducting electricity when you touch it. So it relies on your finger, or specifically the skin in your finger, to conduct that electricity. And if you've ever been wearing a glove and not been able to have your touchscreen operate, that's why. So we're going to get into electricity and conductivity in a chapter as well. And there are many environmental implications of putting all that together, the metals, the glass, the plastics, coming from all over the world and fabricating the smartphone. There's also environmental implications of using the phone, because obviously that uses electricity. And where does that electricity come from? So we're going to be talking about energy sources. And then the question is, what happens to your phone when you're done with it? Do you recycle it? If you do, that's great. Recycling takes energy and energy to actually disassemble and then take those parts, the metals, the glass, the plastic, and find uses for them. I'm going to come back to the 3 pillars of sustainability in Chem 9. And human activities always require consumption of natural resources, and they always result in creation of waste. Even a green activity like biking or walking compared to driving, that's still going to use resources and create waste. And so obviously a non-green activity like driving a giant SUV will just use more resources and create more waste. But since every single one of us does one of these, walk, bike, or drive every day, multiple times a day, and now you multiply that by 7 billion humans, that's a lot of consumption of natural resources and also a lot of waste. Your smartphone is an example of both chemistry and sustainability. From the chemistry perspective, it's the periodic table in the palm of your hand with all those different elements playing a role. And sustainability, economic, environmental, social, there are both pros and cons. We've already talked about some downsides of the environmental, but phones do use less resources than, say, a computer, or can be useful in making life more efficient, like the maps.
Cell phones and portable electronics. We rely on these devices to keep in touch and use them for so many other tasks in our everyday lives. But what does chemistry have to do with these devices? Using our knowledge of chemistry, we can visualize the arrangement of atoms in the world around us. Having some understanding of how these atoms are arranged and interact gives us a picture of how they work. All the materials found in portable electronic devices are obtained and purified through chemical transformations, including the silicon in the processing chip. If we change matter on the smallest scale, we have a new material that may be used for a different application. Chemistry deals not just with the structure and properties of matter, but also with the transformations of matter. Reactions and energy are required to turn raw materials into useful products, and to transform things that have outlived their usefulness back into materials for other applications. This chapter will detail how the fundamentals of chemistry can be used to make the materials found within portable electronic devices and to recycle them.